Okay, so if we can start, you guys have launched fairly recently. I think it's the built to suit service, and there are four main components of that, if that's right. It's aimed at the hyperscale community, if I've got that right. And the building blocks are fund, design, build, and operate. So I guess, can you give us the sort of overview of that that solution?
Yeah, sure. Thank you. So for a number of years now, the hyperscaler community have been dominating the colocation market in various regions, certainly in the European locality. And that's been predominantly prevalent in locations around London and Frankfurt. And as their demand for capacity has grown, so has their demand for tailored solutions that fits within their kind of global remit to replicate their deployments that they have across the globe, and certainly that they have within their own owned data centers. So to support that, and also to support the volume of capacity that they're looking to secure, we've developed the build to suit product. And what we've done with it is enable them to, in effect, take single components out of the entire offering to suit their exact requirements. So as you correctly say, it's got fund, design, build, and operate. In some instances, the hyperscaler may wish to fund the build themselves, so you take that component out, or they may wish to design it themselves, so you take that component out, or we would fund, design, and build, and then we would hand over the facility and the keys, and they would operate it. So the purpose of the product is to provide as much flexibility to some demanding customers in a way that suits their particular business model, their particular approach. And obviously these guys have got access to significant funds, but they may not wish to use those funds for this purpose. And the funding piece is important because as an organization and with the funders that we have, we are able to access a lower cost of funding than some of the competition are able to do, which ultimately makes the design and then the ensuing build a lower cost to them.
Okay, and in terms of the sort of take, I mean, I'm sure you launched it having had discussions with these folks, but in terms of the take up or the interest you've had in it since the launch, can you give us any feedback on what the hyperscalers are telling you?
I can only speak generally. I'm afraid they don't like speaking publicly about
sure.
This.
Yeah,
but certainly. I mean that layer of product offering is great to have it, but if you don't have an access to a suitable location with the right amount of power, then you can't deliver it. So because we have access to that, we are in meaningful conversations and discussions with a number of these organizations that wish to be able to utilize that flexibility and those components of the design to build offering. So it certainly hit the mark, and it certainly has provided them with something that they can consider, which they haven't been able to do so in the UK market up until recently.
Okay, and just before we move on to other things, I think I'm right in saying that the service is also OCP ready, which I'm interested as to what sort of benefits that gives those folks. And also, I think you offer some different levels of agreement. Is that purely on the finance side, or is that in SLAs? Can you give us a bit of background?
The Open Compute project obviously encompasses a much wider area than just the data center, and we are just simply the data center, the land, the building, the facility provider. But it must have been 3-4 years ago now, we went through the process of ensuring that our facility was OCP compliant, and really OCP has been driven by the hyperscalers, i.e. the approach that they have to the deployment of infrastructure on a global basis. In effect, what they want to do from purely a data center perspective is to preload racks of infrastructure, and the highest racks they can possibly get are like 57U in the factory, and then deliver them to the data center, and then in effect then wheel them in from the delivery lorry to the footprint that's been allocated to them, and then drop them down and then plug them in, and then they go. So what that means from an OCP ready perspective is that we have a data center that has the right width and height doors, the right loading bay size, and more importantly, the right concrete slab capability to support the density and the weight of these racks, because the density of this compute is increasing significantly, and most data centers still are being built with raised floors, and those raised floors would need additional support to be able to support the density of those racks, and also the the routes from the loading bay to the data halls as well would need to be increased in load bearing capability to be able to enable that flexibility. So it's all about speed and simplicity, and what you achieve with the speed and simplicity is a more efficient data center from a build perspective, which makes it more cost effective, but also more efficient from a renewable perspective, because you're not using so many materials. It makes it also more operationally simple. So the risk of outages is lower, but it enables a far more process-driven deployment of IT infrastructure, which supports the overarching open compute ready approach. And a lot of this has been driven by the large hyperscalers over the last 5 years anyway. So we felt it would be great to go through that process. And if you read in effect our marketing and elevator pitch, we make it very clear we are proud of the fact that we are learning from those hyperscalers, because they have deployed so much capacity on a global basis.
Okay, and just on that agreement level side, I mean, you different levels of agreement. I say, is that to do with the service levels, or is it the finance pack? Is that how does that work?
Yeah, so the way that the organisation, or that our customers can pick and choose components of the build-to-suit model, enable us to do that and have a variety of agreements, the legal agreements that sit on top of each of those components. But ultimately, if they were to take all the full suite of components and have a build-to-suit offering in its entirety, there would be an operate piece which would provide the service level agreements for the operation of that data center during its lifetime. And they're supported by power and cooling SLAs and humidity SLAs for the duration of the term.
Okay, so the hyperscale is clearly one sort of, I guess, ongoing trend. High performance compute and AI. I mean, AI, everyone's talking about that, whether it's our friends in the government telling us that's the future, to business obviously working that out for themselves. But what are you seeing, I suppose, at the moment in terms of the uptake, interest in that, and I guess as interestingly, in terms of the future pipeline, I suppose where are we at in those markets?
It's an interesting view that you get from the colocation world, because if you go back 5 years ago, or prior to 5 years ago, the majority of corporates were looking at deploying their own infrastructure for very standard servers with 3 kilowatt racks, 3 to 4 kilowatt racks. And as the cloud providers have come into the mix and are in effect providing a great deal of those services that these organizations used to do themselves, the market's changed very quickly, and it's very different now. So what we see are organizations who don't want to utilize the hyperscaler equivalent of HPC or AI, i.e. the NVIDIA GPU technology. So in effect, we have positioned our business not only to address the hyperscalers directly, but also to address those organizations that are deploying HPC and GPU technology, which is much denser in its nature, and also it's more cost effective for these organizations to acquire it themselves than to buy it through the hyperscalers because of what they're doing and how they're utilizing their hardware. It's become very prevalent, and as you correctly say, there's a lot of interest, a lot of excitement about it. A lot of it, you can argue, is hype. There's a lot of organizations hanging off the back of it, but we are seeing genuine deployments across not just the traditional research community who have been using HPC for many years now, but across a wide variety of organizations, certainly in the finance world, who are adopting AI technology, the GPUs from NVIDIA. We're seeing a lot of the pharmaceutical companies now adopting HPC and also GPU technology. And because we're addressing those markets directly through the go-to-market strategy we set out at the beginning of the year, we're seeing benefits, i.e. we're securing contracts on that basis. And what that means from a data center viewpoint is that the traditional 3 to 4 kilowatt racks in our facility, we're probably averaging about 10 to 12 kilowatts on average per rack, which is a big shift up from what it was previously. And what's really interesting now is that because everyone is striving for this greater compute capability, that the need to cool this infrastructure has got to a point where air cooling is no longer deemed to be appropriate. And everyone is now genuinely looking at the liquid cooling to the chip. And in doing so, we are in the process of installing a system of that nature. And I've been hearing that that's going to happen in data centers for the last 15, 20 years. The only organizations that have really done it are the really large supercomputing users, such as the Met Office. but now I can genuinely see that being far more prevalent. And I think with the colocation providers, the importance is that we get to the point where we are able to, and we can demonstrate that we can support that environment. And I think that will be the next shift in the colocation sector, the ability to not only provide an air-cooled storage server, but also to provide a water-cooled compute server next to it, and be able to facilitate both those technologies and cooling systems in the same data hall.
Okay, because I mean, I was going on to ask, how would you characterize, I suppose, an AI or high performance computing ready data center, or flip it the other way? How can you tell a data center that clearly isn't fit for coping with those kind of workloads?
The way that the cooling infrastructure is deployed, if it's traditional chilled water pipework around the room, with crack units in the room, with a raised floor, with cold air containment, you're going to really struggle to do that. And you could not argue that is, or it'd be very difficult to argue that is an AI HPC enabled data center. Having a concrete slab floor with the load bearing weight that can support the much heavier infrastructure that the higher density hut servers do demonstrate, but also being able to combine a cooling solution that can bring in the air into the room, but also provide the pipe work to the rack to enable this on-chip cooling is crucial. And if you can't demonstrate that, then you don't have an AI HPC enabled data center facility.
So yeah, I was going to ask about, so the liquid cooling, because obviously, as far as I understand it, it happens within the server, or at the chip level, or certainly at the component level. But you guys, I think you just explained, are responsible, if you like, for the liquid getting to and from that. So it's a sort of joint. Do you work with the server guys or the actual end user who's server? How does that, I guess,
so
work?
The hardware server providers, if you like, who bring together all the components in the box, are working with other parties to enable that coolant to come into their box, and they're obviously having to ensure that those boxes are watertight and that it creates the right environment to be able to cool the chip. There are manifolds that sit around the rack that we provide the coolant to, and then that coolant, that demarcation point, is the point that they take the coolant to the chip within the server.
And you referenced the sort of the higher densities that are being required. I guess one of the major things with data centers at the moment, I won't say they're under the pump, but clearly the environmental angle is always present and maybe increasing a bit. How do you, I guess, meet those two potentially conflicting? There's more and more power required for higher performance compute, but we're also, all of us, and data centers maybe in particular, being told to be more efficient or even reduce power. I guess, how do you sort of meet both of those obligations?
Yeah, I mean, everyone talks about PUE. I know I'll try not to talk too much about PUE, but I think it's important that your design, your cooling design, that you can stand up to it. So, and the only way you can stand up to it is to contract to it. So we contract to PUE of 1.2 for the cooling within the environment. So it's as efficient as we can get it in the UK, with the climate that we have, which does support a lower PUE than other countries. We are in the UK, so we are somewhat restricted in how we can access genuine green energy. We are reliant upon the national grid to do so. And again, our commitment, and again, this is a legal contractual commitment, is that we will secure and procure renewable energy from the grid and provide those certifications through to our customers and demonstrate that. The only alternative really is to go and build a data center next to a wind farm, and take the energy directly from the wind farm itself and plug it into the servers. Very simple view of how it would work, but that's the alternative. The commitments we have from our energy supplier is that they will procure the equivalent amount of electricity from green sources that they then sell to us, and that's how the renewable certification process works at a very high level.
And just before we wrap up, I guess on that front, do you think there is more that the data center industry as a whole can be doing, or do you think, as you say, with the PUE, the focus on getting the most out of the energy that is being used, and because, as you say, if you're in the middle of London, you ain't near any renewable energy, etc. What do you? I suppose, is there anything more that the data center industry can be doing?
I think the data center industry is probably a little bit too guilty of doing things within its own field or its own area, and kind of seeing that as the only influence that they can have. I think the data center industry has got an opportunity to go much wider, get involved with government much more than traditionally and historically that it has done so. I know that a lot of work has been done in that regard, but I still think we're scratching the surface in getting to the right people in power within the government, in politics, to explain how important the data center is, or the data center industry is, to the economy and to the country. I think we can go beyond that and start getting more involved in the renewable efforts and developments of renewable plants across the country. And I think it's something over time it should be entwined with that. So data centers should be adjacent to renewable energy farms, whatever they may be. And there should be a co-investment approach from the investors that look at the data center opportunity, but they should entwine that with the renewable or green energy developments as well. And if you can bring those together, then I think you create quite an interesting business model, but you answer and tackle the challenges that the data center is being tasked with currently.
Okay, so I mean, we've covered your new service. We've talked a bit about AI, HPC, and then I mean, are there any other sort of buzz topics you see in the data center space at the moment, or looking ahead? Clearly, we're all wrestling with this wretched pandemic, but I mean, apart from that, are there any other sort of things you can see on the horizon?
I mean, going back to the AI, GPU, and HPC environment, I think that the market shift is happening now, and I think that's going to be a major factor and a major piece of data center considerations in the future. You know, we are located in what's termed the UK Innovation Corridor between London and Cambridge. There's a great deal of science parks, research institutions, pharmaceutical companies there that in the past have done a lot of their compute on site, and they're now struggling to do that because they are in the process, or they are acquiring, or they're soon to be acquiring the next step up in the HPC world. So they're going from petaflops to exaflops. And though technology has advanced so much, they are generally using, or the servers are using less power than, or they try to use less power, but that step up is still going to increase their power demand. And they're struggling to be able to support that within their own computer rooms or data center facilities. So they're all looking at an alternative and a means by which to support their need for more compute in the future, and to also enable that. Their research teams are located on campus, and in the past they've had their HPC cluster next to the research laboratories, and they've had fiber between the two locations, and that's fine. But if they try and off-site it, it's too far away, and they can't just use the internet to access it. So they need to come up with a solution for direct connectivity with multiple 100 gig wavelengths to ensure that their customers, i.e. the research institution or the researchers, will be enjoying the same experience that they do today, and also achieve the step up to the exaflop world, as everyone across the globe is now achieving at the moment, certainly in Europe and in the Far East and America.
And on the sort of HPC finding, how far into sort of, I suppose, general business do you think? Because you know, traditionally scientific research, as you say, is its sweet spot, but with this AI sort of focus as well, do you think your average high street business will at any stage get into high performance compute, or is it still going to remain sort of slightly sort of out there for the the people that got the really heavy data workloads?
Yeah, I think the finance world is embracing it massively at the moment. They're all scurrying around. They're one of the largest buyers, or one of the largest growth areas for the purchasing of the AI GPU technology. If you look at any organization that does any type of modeling, any CFD modeling or anything of that nature, the GPU technology really fits in well with what they want to achieve and can do it much quicker. And over time, we'll get a lot more players in that field, and it will drive costs down for the users of that technology. Whether or not the high street bank will use it is something that's debatable, but AI, driverless cars, and all that stuff is all on the horizon. I know everyone talks about it. It all seems a little bit pie in the sky, but it does seem to be happening. And if you go and speak to NVIDIA and the likes, their sales figures speak for themselves. So I think it's quite clear to me that the adoption of this technology is happening. It's not just articles being written and a lot of hype from the actual vendors. People are buying it, people are doing it, and they're looking to utilize it, and they're just trying to find a home to house it.
Okay, you've given us some great insights into both yourselves and the market in general. So, Spencer, thanks very much indeed for your time.
My absolute pleasure. Appreciate your time.